So I'm Gil, I'm from Climate Scale as well as Vortex. My presentation is gonna be like an introduction to the climate modeling data that we use to assess the climate projections and information that is needed to employ if we want to infer information about future condition of the climate and in the context of climate change. And also I wanted to give some other thoughts about how climate variability, and in particular the forced variability by climate change, should be included in the wind farm and wind resource assessment field. We know that the climate is changing. This is something that is really, I'm not going to go into all the details. I am smiling because Anna always told me that I say this sentence. And I'm not going to go into all the details because there are many details when I see this picture that I'm not going to go through all what is behind all this information. But we know that the climate is changing. There are multiple lines of evidence, data, and obviously the danger of the impact that we are seeing now, and the impacts that probably we and our sons will see in the future. So it's not, when looking to the climate change, and in particular wind, it's not only about changes on average wind speed that are very relevant. Probably is the first level of information that we want to get. But it's also about the streams this summer. And this is an example of a stream we experiment in the Mediterranean that was a mesoscale convective storm that developed in the Western Mediterranean and traveled from the Balearic Islands, even close to this Valencia, up to Prague, passing through Corsica, Venice, etc. And this was an event that in the US, they know quite a lot about this event, this convective event, but in Europe, it was maybe the second, the third time we have this kind of persistent mesoscale convection storm that normally takes few hours, and here get enough energy to develop over a large domain, large area, and hit Corsica with a speed of 65 meters per second, which makes us think if someone's compute a VREF of a wind farm in the south of Corsica before or after the summer, there will be a new point with a very huge stream. So, and very important, this is related. I don't want to do an attribution analysis. This is going to be by the community. But what's very important is to signal that the temperature over the Mediterranean over this since May to August were really anomalous high. Has a huge impact on the ecosystem, but now we see that could be a driver of this situation. There is all other things that are changing that are not just forcing, and this is something that is going to be discussed by John after me, which is looking to something that has been in the community for a while. Maybe we don't want to look very directly to the eyes of this wind stealing because they were pointing to something that we don't want to hear, that global wind resources are getting lower, etc. There has been a lot of miscommunication about this event in the media. That's, I think, you need to know. So John is gonna, I think, I saw his presentation. I think it's gonna, it's sure that he's gonna give quite a lot of interesting perspective to frame and to understand, which is the variability that is not captured by the interannual, the 20 years that we use to assess the uncertainty, the climate uncertainty, but going beyond. Here is an interdecadal variability signal, natural or not, you tell us about. And also, there is also other aspects that are, for instance, changes on land use are also, we wanted to cover this, but at the end, we will leave it for another workshop. But there are also the role of land use. But no, I don't mean land use for a particular wind farm location, but land use changes at regional scale that we are seeing and we will see in the future, especially if we need to put in place mitigation solutions that capture carbon and And this is something that also can be evaluated with the climate projections. So all this information that I mentioned, that is the variability of the wind foresight or interdecadal, is being considered in the wind resource analysis practice. So the natural variability, the 20 years variability that we can expect on a climate project and a climate wind farm project is there. For science, almost the beginning of the wind resource analysis. We have better data. We have the reanalysis to reconstruct the climate. We have downscaling, all the MCP methods, etc. So for that, we are done. We are good. Then interdecadal, that could be the interannual variability, the internal variability, the natural variability, but that you cannot cover with only 20 years. So modes of variability that has cycles of 30, 40 years, depending whether you are in a positive or negative phase, might induce lower or higher, for instance, wind conditions. This is not covered with 20 years of data. And then there is as well the forced climate variability, the climate change, which is another element that plays a role on the perspective, because wind farms are analyzed using historical data, but they produce the energy in the future. So that's why this the question of whether the climate in the future is similar to what we have in the past is something that we need to start to question. So this is an example of a typical, well, it's a real case. It's area 5, one location in the REC, and this is the time series of annual wind speed for that location. This is basically what you will use for your energy yield assessment. If you want, now you have the capacity to reconstruct this climate 20 years back in time using reanalysis, for instance. And even now, and this is something that thanks to Copernicus Climate Services and ERA 5, we can even go further back on time. Obviously, there is an uncertainty when we go beyond further than 79. That is when the satellite, the meteorological satellite, the reanalysis has less data, and obviously there is an uncertainty that I'm not gonna go into details how we should address this now. But if we compare, okay, we look to the past, and there is obviously signals of variability. Are these signals big enough? So for instance, for this case, if we use ERA 5 as the through, which is obviously almost the through, but we could say that for this particular location, the interdecadal variability in this region could have an impact of minus 1%, which probably is not enough. And when you assess the interannual variability, and you might probably have already been protected about figuring these changes. But if we look to the future, what we don't know is, in top of this interdecadal variability and interannual variability, if there are going to be more changes, more factors that make the wind going up. So this is an opportunity. This is things that is positive, no risk. If you are in the safe zone, so more or less what you are protected with uncertainty analysis that you do, or if the things are becoming too low, so you start to be at risk. And this is something that the thresholds, and Sebastian knows, because we've been discussing this idea of thresholds, are depend on the project. The projects, one changes are more important than the other. So here the rest of my presentation, I'm gonna focus on just in climate change aspect, and I'm gonna give an overview, because I think it's important for the community, the wind community, to understand where this data come from when we start to look to the future. So how we infer information of the future, you've seen probably this kind of graph in the media, no? Temperature growing, different pathways, different level of growing, depending on something that we call scenarios. These are related to high or lower levels of emissions. This data comes from the climate models. The climate models are, for the general, the weather and models that run for, not for to the weather forecast, but running for decadal and for multiple decades, in this case, with different parameterization, initialization, because it's a climate tool. What you need to know about these climate models is that they have different components, and this is important: atmospheric, ocean, cryosphere, land surface. So it's not like as simple as when you do a downscaling with the world, that you focus in improving the atmospheric circulation because you run the model for short periods. Here we need to understand what is the role, the memory of the ocean, how the changes in the cryosphere can impact the circulation and also the land surface. In climate projection models, use it for understanding and evaluating the climate change. There is a very important project called CMIP. There are two. We are in the middle between two of these CMIP projects, CMIP 5 and CMIP 6, and these are the source of all the climate projections information that we use. These are projects that get information from 40 to 60 models, have coarse resolution, because here the idea is to simulate the climate in the past and the future in the scale of 1 century. And so it's not to give you the particular weather tomorrow in Hamburg. And there are as well some projects that run regionalization using regional models. This data comes from the reference institutions in the climate services across the world. Some of the models are part of the same family, so there are models that are more similar to the other. Some of these models are using the core that this institution used to do their weather forecast. So it's a model that has been tested in the strongest laboratory for a weather model that is producing weather information every day. And behind each of these models, there is a lot of assumptions. So, because this is the way to cover all these components. These models are initialized with information that comes from what we call the control rounds. That is, how was the climate before the emission started to rise, so in the pre-industrial stage. And then they have like the prescribed forcing, so it's the greenhouse gases, solar forcing, land use changes over time, etc. So this is how we, with this model, we expand from the pre-industrial to now to the future. And there are many experiments. Some of them is what are focused on particular